With ASAP, not only can we look at where the rays go through our optical system and analyze the energy on different detector type surfaces, we can also look at what happens to the energy as it's propagating through the optical system from either our rays or our wavefront. Let's look at an example. In this case, what we're going to do is launch some rays through our optical system, in this case a simple imaging lens. And we'll watch those rays as they come to a focus, and we can see the caustic region, the different concentrations of energy as we get near the focus due to the spherical aberration in the optical system. And we can analyze the energy anywhere along that path. In particular, we're picking a region near the best focus. And we can see the distribution of rays within that volume. But we can also look at some information about the energy as well. And as you can see, we see a nice view of the caustic region of this system. Let's hide the rays for now, and I'm simply going to select the rays from the menu and choose to hide them. And I think I'll also hide the lens. This will allow me to zoom in on our fluence distribution. And what we see is a series of planar surfaces that have been put in place by ASAP, and we can look at the energy distribution as we propagate through this volume. We can also hide some of these surfaces as well, which will allow us to select any particular surface and sweep the plane through the volume, allowing us to get a better indication of what the true distribution is of the energy. Now, another purpose for this type of analysis is for systems which would not only absorb the energy, but also then re-emit that energy. So let's look at a file that will demonstrate this. And what we're going to do now is not only show you how the energy is absorbed in the volume, but that absorbed energy will then be turned into a source with a different wavelength, and then we can look at the fluorescence phenomena as well. We see our light. It will be entering and absorbing media. And we can see that the ray concentration decreases as the light propagates through the system, as would be expected. And what we're seeing here is, in the colored plot, what we see is the energy available. Lots of energy at the front and then very little energy at the back. And in this particular case, what the points indicate is where energy is being re-emitted because of that absorption. And more energy will be re-emitted at the front, where there was a lot of absorption, and statistically less energy towards the rear, where less energy was available to be absorbed. And in this case, let's hide the energy distribution so we can get a better idea of where the rays will be emitted from and approximately the concentration of energy that will be re-emitted as a function of this fluorescence.